In this video, we're going to go through an example of how to name an alkane. So on the slide here, we have drawn an alkane. Our first step we're going to do is to figure out what is our longest continuous chain. Looking at this alkane though, we want to pick a chain that won't have any branched branches. So I'm just going to highlight one chain and show you what I mean by that. So let's say I picked my longest chain, or I picked this as my chain I was going to use. So this would be my parent chain. The issue with this chain is I now have this weird branch circled in yellow. We don't know how to name that. So we want to make sure that we're picking a chain where the branches are all simple alkyl groups. Okay, so we're going to pick our longest chain. I'm going to highlight a few different chains and we're going to work off of those. So starting here in red, this is an 8-carbon chain. In yellow, I'm going to highlight another. That is a 7-carbon chain, so not our longest. So red is still kind of victorious here. And then our last possible option is going to be in green, or sorry, we have 2 more possible options. And that's 6 carbons. And then last but not least is going to be in blue. And that is 7 carbons. And so looking at this disaster on the screen now, we're going to go with this 8-carbon chain as our parent. So I'm going to highlight that chain for us again in red. This is an 8-carbon chain. 8 carbons means that our prefix is going to be oct. There's no double bonds in this chain, so the suffix will be ane. So the parent chain here is octane. So we know our parent chain. Now we want to figure out what our branches are. So I'm going to circle all of our branches here in blue. So these are alkyl chains coming off of our parent. We want to name all of these branches by how many carbons there are. So I'm going to start at the left. This is a 1-carbon branch, so this is a methyl branch. So when we make it a branch, we change the suffix to methyl. We have another methyl branch on the far right, so 2 methyl branches. This second from the left, there are 2 carbons here, so that is an ethyl branch. And then lastly, 3 carbons, this will be a propyl branch. So we've named all of our branches and we know our parent chain name. So next thing we're going to do is come up with location numbers. So looking at a blank copy of this again, we can number our chain going from either left to right or right to left. So if we start on the left, 1, 2, 3, 4, 5, 6, oopsies, I do all of 7, 8. If we go from right to left, we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we're going to be consistent. So our numbering will either be all of the red numbers we have or all of the blue numbers we have. Now, we want to look at where our branches are located. So I'm just going to circle these in green, 3, 6, 4, 5, 5, 4, 3, 6. It ends up being a tie. So if we look, we have in red 3, 4, 5, 6. In blue, we have 3, 4, 5, 6. So that's a tie. And so we're going to give preference in the red direction so that our ethyl has the lowest number, our first alphabetical. Okay, so I'm going to just, on a blank one now, I'm going to kind of summarize what we've done. So our parent is octane. We have methyl here, ethyl, and propyl. And then our numbering goes 1, 2, 3, 4, 5, 6, 7, 8 from left to right. Okay, so when we put all this together into a name, we're going to start alphabetically. So we're going to put first the location. So 4, our ethyl's on carbon 4, 4-ethyl. Then our next alphabetical is methyl, so M. And we have methyls on carbons 3 and 6. So we say 3, 6. And then a dash, we put the word di, meaning we have 2 methyls. So same prefixes in molecular compounds. Dimethyl, 5 propyl. Oops, I'm running out of space. 5 propyl octane. So no space between our parent and our groups ahead of it. And so if we look at that, oops, definitely not going to fit. There we go. If we look at that all out, this compound would be called 4-ethyl 3,6-dimethyl 5-propyl octane.